Hello and welcome to another one of D's ADD videos. Today we're going to be discussing the concept of Ka and pKas and Kbs and pKbs. So if we were to look at the general Arrhenius acid reaction, we have the acid plus water gives us H plus proton, or the hydronium ion H3O plus, it's interchangeable, plus the conjugate base of this acid. Okay? And if you were to look at the equilibrium constant, in this case, because it's an acid, we call it the acid dissociation constant. It's always products over reactants. In this case, the products are these two, and the reactants, even though it's these two, H2O being liquid doesn't show up in the equilibrium expression. Ka is directly proportional to acid strength. What does that mean to you? That means that the larger the Ka value, the stronger the acid. Now, because the range of Ka is so wide and varied, you can have really weak acids with 10 to the negative 40 Ka values, and weaker acids that have values of 10 to the negative 3 approximately. So in order to narrow the range, we can use a logarithmic scale, logarithm base 10. And what that allows us to do is compare acid strength on a much more condensed scale. So strong acids typically range about around 0. Organic acids roughly greater than 4. Weak acids can have larger pKas, greater than 40 or so. Okay, so that's basically pKa. Remember, Ka is directly correlated to acid strength, proportional, whereas pK is inversely proportional. So using the same logic, we can discuss Kbs and pKbs. Here's the general equation. This is your base. Reacting with the water in the classic Arrhenius definition, and it's going to give you the conjugate acid and the hydroxyl ion. So if we were to use products over reactants for this base dissociation constant, we would get this equation here. Again, that range being too large, we take the pKb value of that, and it condenses the scale a lot more. If you want to interchange between one or the other, for instance, you're given pKa and you want to go to pKb or vice versa, just use this equation here. It relates the two. So just plug in and solve. Now, if you were to multiply Ka and Kb, what happens is the acid on top cancels with the acid on the bottom over here, and the A minuses cancel from the top and the bottom, and the only thing you're left with at that point is just the hydroxyl ion concentration times the proton concentration. So when you multiply these, you get the water ion product constant, and it allows you to go from either hydrogen concentration to proton or to hydroxyl concentration. Sorry, it's early in the morning and I've been going for a few hours, so a little tired. So if you want to switch from either Ka to Kb, you can use this equation, or if you want to switch from hydroxyl ion concentration to proton concentration, you can use this equation. Either way. So that's basically it for pKbs and Kbs and all that good stuff. So make sure you use each equation, be familiar with them, and check out the example videos with some problems on each. And most importantly, practice, practice, practice. It's really easy to see somebody do it for you. Question is, can you do it on your own? I hope I've cleared up any doubts you might have. Thank you and have a nice day.